Hi guys, Assalamu alaikum everyone.
How are you?
I'm good, Barsa. How are you?
I'm good, sir.
All right. We've got a couple of new people joining in today for the very first time. Yes, could you kindly tell me your name, please?
Assalamu alaikum. My name is Minahi Lakir.
How are you, Manahil?
I'm good.
It is good to know. And Assalamu alaikum, Naufal, you're here too.
Welcome, Salam.
All right. And yes, there's an, I think, there,
Assalamualaikum. My
yes,
name is Amna, and how are you, sir?
I'm good. Amna, how are you?
Alhamdulillah.
All right. So, just before we begin, Amna and Manahil, when are you guys giving your exams? Minahil, when are you going to sit for your AS math exam? Is it going to be in May, June? Yes, Minahil.
No, sir. In like October, November.
All right, no worries. That's perfectly all right. And what about you, Amna?
Same, sir. October, November exam.
That is good to know. All right, guys. So we begun this course since Nofal and Parsa. I'll just take like a couple of minutes. Just trying to introduce ourselves to Amna and Minahil. All right. So both of you guys, we've begun the course from the 2nd of January. So it's been like almost one entire month, couple of days more. So what we've done is that we've covered the first few chapters because we've been going at it for a month, and we're almost done with the first three chapters, if I'm not wrong, or four chapters for P1 first. All right. So we have, started off with quadratics. I hope everyone can see my screen. We've started off with quadratics and we've gone through with it. We've discussed how many types of questions there are and stuff of that sort. We've gone for graphical examples as well. Apologies for people who find this a bit annoying, but I love my notes to be really colorful and stuff of that sort. That is why you will notice a lot of colors there. Also, then in my classes, there's always going to be one focus is going to be extremely big. Like we're going to focus very much on the fact that it's supposed to be very past paper question oriented class. So whenever we're done with, let's just say that any topic we're done, anything that you see written with white is probably going to be a question. And what I try to do is that I try to make sure that different types of questions are discussed so that you guys already have an idea as to what types of questions can come. Because if we're just doing one generic question all over again, it's not really adding up to your arsenal. What we want is to build your ability to do many different types of questions. Like, for example, in quadratics as well, you could be asked a question regarding disguised quadratics or anything of that sort. And then we finished up. And once we're done with a particular chapter, also, apart from the three classes that I have during the course of the week, there's going to be one test class as well, which is going to be taken by a colleague of mine. What she's going to do is that she's just going to invigilate. She's just going to sit there in the class and make sure you guys do the worksheet in time and submit it on Google Classroom. What is going to happen is that I am going to be the one that is going to be sending in the worksheet to her, and I will be obviously be the one that will be checking it as well. And personal comments and personal remarks on that worksheet, I will also be providing to the students in general too. All right. And this is an example of the worksheet, just, simple past paper questions that I felt as if you guys should do. I gave them to the class. And also, one more important information is we have a Google Classroom. Every sort of announcement and every, even, the announcement of the class that, that the class has begun, and if there's a makeup class or anything of that sort, that is also done throughout through Google Classroom. there. And also all the notes and the class recordings, every class is recorded. So if by chance you miss a class and for example, you're joining in late, maybe you can just refer back to the notes and the recordings from Google Classroom. And also I'm also available in every class there is going to be, and you can just come back to me and ask me questions. Then after quadratics we did coordinate geometry, by far one of the most easiest chapters these 2 hours. Like for example, quadratics is really easy as well. You probably most of you have done it in IGCSE, and hopefully you guys remember it from IGCSE as well. It's just a continuation from what you've learned in IGCSE, both these chapters, coordinate geometry and quadratics. Very easy chapters, nothing to be, you know, afraid of or anything. Usually students like to refer to these few chapters as, that they're kind of like free marks. And why are they, referred to as free marks in the exam? Because it's very easy to score marks. For example, in every paper that you're going to attempt, you will see that there is almost a 8 to maybe a 10 marker, even a question of 10 marks almost, that is on coordinate geometry. Now coordinate geometry, you've been doing it since almost like grade 6, so it's obviously the same coordinate geometry is not going to be there. It's going to be slightly more complex, according to the A level standard. But nonetheless, it's compare if you compare it with the other topics like trigonometry and differentiation and integration, it is a bit very easy as compared to them. Then you can clearly see that, we did circular measure and stuff of that sort, some related questions. Then we did transformations. And, if by chance you guys do find the opportunity to, join us, do check out the videos of transformations of this class as well, because I think they're really helpful because we didn't really do it over here. I taught the entire class there's this app called Desmos. Parsa and Nofal seem to think that I am somehow sponsored by this app because I really love this app a lot. And it's really helpful for me as a teacher to, explain graphs on that app. And I'll just show it to you guys as well. And I would like to add that I am not sponsored by this app again, although I was just using it in my previous class as well. It's a very good app. I hope you guys already know of it. If you
So if
don't,
I was you, I'd ask them to sponsor me.
what, sorry?
So, so if
Should
I
I?
was you, I'd ask Desmos to sponsor
Yeah,
you.
I think I should actually.
Yeah.
I don't think, because I
And
advertise
also, if you're
them so
gonna
much.
keep promoting them, you might as well get paid for it.
Yeah, actually, I don't know, Parsa. I really like that. Okay, the only explanation that I can give to promote this a lot is that, I didn't have this when I was doing my A levels, which was a long time ago. But if I had this in my A levels, life would have been so much easier. Like, just you write down a graph, any graph, and it just makes the graph in front of your eyes, and then you can add like sliders and stuff. So if you remember, Parsa, when we did those transformations, it was really easy for me to explain it to you guys, like how does it happen, and you can show movements of the graph and stuff of that sort. So it's like really fun uh, for people who are like, uh, um, lazy like me. I can say that you do not want to draw the graphs. I can just simply refer back to the graphs, and it's really easy. And I think it's understandable for the students too. And yeah, I think they should sponsor me by now. I'm really, like knocking at their door for something. That's what I'm doing. All right. Yes, Amna and Nahil, we did then obviously, and the tests are also there. So I give these guys a test. It's just purely a past paper. I just literally, copy paste past paper questions. That's what I do. Sometimes I just entirely throw a past paper there, no copy pasting as well. And what is the best part about this is that obviously we know how we're going to do the questions, and we learn how to do the questions as well. And the best part about this is that we understand if you're lagging in some sort of aspect or not, or something of that sort happens. All right. Then I'm just going to fast forward a bit. We did functions. We learned what functions are. Functions are similar to the one that you have studied in IGCSEs, but we're just going to build on that. And then we did, the different types of functions. And then I did, inverse, domain and range and stuff of that sort. Then we did a few types. Like you can clearly see over here, we've got type one, type, because students find it difficult to understand what to apply on what question. So that is why I was trying to, divide it into types of questions and types of, what the examiner could possibly ask you. So we were doing it in those terms, and we saw throughout this how to solve it, and we went through with this. We did graphical representation. Again, this MOS is very good to try it out. And yep, again, okay, now this was a test that I gave these guys, and then we solved it in class. Now what usually I do is that I first give you guys the opportunity to solve it, and then I solve it in front of you. This actually, what happens is that this helps you to understand how to do the question, and it also helps you to understand what you may say, how the examiner would mark the question on what he requires from you, because sometimes students do a whole lot of working just to get 3-4 marks. So sometimes, if this is a 4 mark question and I've only written a handful of stuff, so this shows that you don't require quantity over quality. And then we did a few questions over here. And more questions. And then lastly, I think it was last week, we began and ended trigonometry. We saw, began from the very basic, even though you guys would have had knowledge of this before as well. We began really basic and, started with graphs and everything. We saw transformations, further graphs, and this looks very cool, by the way. I've just noticed that. All right. And we did some further properties. We did exact values. Then we also did. Now, my entire class is all about, trying to understand what sort of type of questions you're going to receive. Because you're going to have a lot of information and a lot of knowledge, but you need to apply it there. So we're always going to be discussing what sort of types of questions can come to you. Secondly, solving the identity, and we've got different identities, how to solve them. Then we did a few questions, and I did questions with multiple methods, so because you can choose whichever one you like. Did more questions, a lot more questions. Then we did equation solving. I gave a step-by-step guide as to what you're going to do, like step 1, 2, 3, 4, 5, and we got through with these questions. And then last, I remember Nofar, Tariq, and Parsa, I gave you guys a bunch more of questions. Yes. Did you guys do them, Parsa and Nofar?
Yeah, they are submitted.
Yeah, I'm excited it, but
Some were having an issue with them. You
I
guys having issue with them?
about to submit.
Yeah, one question.
Uh, Great. I think I sent you guys 2 worksheets. So this
No,
is
sure. On Tuesday, we only had one worksheet.
no, on Tuesday you had the one, and then there was one that I gave you in class.
Yeah, yeah.
Hmm. This is the one where we did this is the one that I gave you on Tuesday, the other teacher
Yes.
one. And this was above it as the one that we did it in class. All right, all right.
Yeah.
And yes, and Minahil and Amna, any questions that you might want to ask me?
No, sir.
Anything at all, like anything that you don't get, anything that you would like to add? Yes. Any question from you, Minahil?
So, can we like get recording of the previous classes?
Yeah. Usually, okay, thank you for doing that. Parsa, do remind me to post the recordings and the notes. I have to update because, we're recording every class. So I'll try to update the Google Classroom. By the way, I think I told you guys, Amna and Minahil, that we have a Google Classroom. So if you could kindly share your emails, and kindly do it on WhatsApp, so that if you do it on this chat, usually students do what is that they send the email on this chat, but the problem is sometimes I forget to copy them down and close the chat and end the call. so they get lost. So after the class, maybe, or during it, whenever, just send me a message or probably email it to me. If you guys want to know my email, hopefully, let me give you guys my email too, so that you guys can send me your email, and I can add you onto the Google Classroom. Yeah.
Okay.
All right. Amna, any question from your end?
No, sir.
All right. So on Google Classroom, obviously, I'll be posting, and also feel free to reach out to me anytime at all, even after the class. Just if I'm not available, you can email me, you can text me. I'll get back to you sooner or later. Usually, it's later because I reply back really slowly, and apologies for that beforehand. All right. Yes. Now, Parsa and Nofal, where were we? We were done with trigonometry, right? Yes, I think so.
Yeah, we were supposed to start like
Series.
binomial expansion and the series.
Yeah, we were supposed to start that. But what about the questions that you had done? You guys had issues with the questions. We obviously need to discuss those first.
Yeah, I had like issues with questions.
Question number what? Like you had an issue with this worksheet, right? No, this one we did. I think it was this one. This one, this one, this one, this one, this, this question, and that's it.
There was
So let me bookmark these. This is one question,
I was stuck,
right?
but
Already.
here it shows that I did them.
No worries, we'll do it. Amna and Minahil, have you guys done trigonometry before in AS?
Yes, we have done a little.
All right. And do you guys know each other?
Yes.
All right, that's cool. That's cool. It's actually very well to know. And also, we're going to have like a really interactive class. I do not speak this much usually, so I'm going to require a lot of feedback from you during the class as well. All right, so it's not going to be like you're just going to stay quiet throughout the class and it will just go away.
No,
Right.
yeah, I'm sure the third and fourth questions I
Hmm.
did not do.
All right, that is perfectly all right. Amna and Minahil, we're going to be discussing a few questions. I hope that's all right with you.
And Mr. For the first question, the first part we did it before in class, so I just skipped it.
I think we did this. When did we do this? This question, I think we did it before.
Yeah.
Still remember as well. Let's do this part of then. All right. Okay. Where were we? All right, guys. So, okay. And I'm under the impression that Amna and Minahil have already done this before. So I'm just going to go through over the questions. Do stop me wherever you don't get anything. All right. Okay. Nofal and Pasha, have you solved this question?
Yes.
Nofal, can you guide us through it? Did you solve it correctly?
Yeah. So, Mr. We all
All right. Parsa is going to take the lead. Yes, Parsa.
from the previous part, we already know that sine theta over sine theta plus cosine theta over sine theta minus sine theta is basically equal to tangent squared theta plus 1 over tangent squared theta minus 1. So we just replace that equation by that. So it's equal to, so tangent squared theta plus 1 over tangent squared theta minus 1 is equal to 2.
Okay.
Then we cross multiply,
All right.
and then we get 2 tangent theta minus 2 is equal to tangent theta plus 1.
Okay.
And
We
then,
just multiplied this guy over to this point. Okay. Now we've already bypassed the first step. What was the first step in solving equations? That express the given trigonometric equation in a single trigonometric identity. But sometimes, you're not required to do so. You can already, like the question that we attempted in class, it did require us to, first try to simplify it in a given trigonometric identity through a given trigonometric identity so that we can convert it into a single trigonometric identity across the equation. But this time around, our entire equation is already in tan theta, tan squared theta. So if I simplify this and
We just
I,
get tangent squared theta is equal to 3.
hmm,
And then we do radical, and then we square root both sides. We get tangent theta is equal to radical 3.
all right, so if I square both sides in order to remove the square term over the what you may call, obviously there's going to be a plus minus sign over here. And in this question, you also don't have to use substitution. Usually, what I've written above is, if I'm going to refer back over here, it says that use substitution for quadratic equations. But in the question below for the tan theta one, even if you don't use it, over here I had to use it because the equation was a bit complex. Using a substitution just makes it easier for me. Even if I don't use it over here, I can simply, try and get a value out of tan theta. Yes, Parsa, continue.
Yeah, and
So
then
tan
we
theta is equal
find
to,
alpha, which is our reference angle.
okay, first of all, tell me, can I use these two values?
Yeah, you can use both of them.
All right. Now, usually what happens is that for tan, why does it not recognize the square root at times? Yes, no, it does. Now, oh, apologies. Now, this is suitable for tan alone. Why is it suitable for tan alone? Because tan theta, if you were to plot the graph of tan theta, it goes from positive infinity to negative infinity. Whereas your graphs for sine and cos, they do not extend beyond 1 and -1. So over there, these values would have been some sort of cause some sort of an issue. All right. Yes, Partha, what should I do next?
So
This
then
number?
we find our reference angle. So, and we make sure our calculators and radians, because
Yes,
they ask for the angle in radians.
very well done. Excellent, Partha. Yes. So
So
the
it gives
answer,
us
it should be in radian.
pi over 3.
Sorry.
It gives us pi over 3 when we put tan inverse radical 3.
And if I put tan alpha, is obviously when you're trying to find the basic angle is always positive. So
Yeah.
regardless of whether it's negative or positive, you're just going to find. And if someone's wondering what the basic angle is, it is just simply an acute angle, a positive acute angle subtended with the x-axis. So your basic angle is always forming with the x-axis, and it actually leads us to, your actual angle. Yes, Partha. So what's the
So
answer to this?
we get pi over 3.
Pi over 3.
And then, Mr.
That's
For the
almost like 60
positive
degrees.
values of tan theta, it's in quadrant 1 and quadrant 3.
Wait, Partha, wait. Hold on. So identifying the quadrants, now you can have tan as +3 and -3. So technically my angle exists in all four quadrants.
Yeah.
So it's
But
going to
Mr.
exist.
When you find the values in all four quadrants, you only take the ones that fit in the range from 0 to pi.
Yes, Partha. Very well done. You remember this. So it is going to be existing in from 0 to pi. So technically pi is 180. So your this is 0, not degrees, but 0. And this is pi. So that means that my range is just this. That's my range. Cannot go beyond this. All right, guys, what should I do next? Yes, person. So my angle is going to be either like this This is my basic angle. This is alpha, which is pi by 3. And alpha on the other, what you may call quadrant, is going to be pi by 3. Now, technically, if you look at it from this point of view, it is going to be, all four quadrants should have been used because, tan theta is positive or negative, but our range did not allow us to go beyond these quadrants. So obviously one angle of yours is going to be like this. All right. And another angle of yours is going to be like this. So my first angle can be exactly as my basic angle, which is pi by 3. My second angle is obviously going to be pi minus pi by 3.
Which is 2 pi over 3.
Yes, Parsa. So what is my final answer going to be, Parsa?
So it's pi and so theta is equal to pi over 3 and 2 pi over 3.
Pi by 3 or 2 pi by 3. Nofal, is this square? Yes, Nofal, is this square? Hopefully this is clear.
Sir, I got the exact answer.
All right, that is fair. And Amna and Manahil, any questions regarding this?
No, sir.
Amna, is this fair?
Yes, sir, it's clear.
All right. If there's any question, let me know, okay? All right. So let's just know the marks breakdown for this question. So the examiner is probably going to give you, if I break it down, you're going to get 2 marks for the, the answer. You're going to get 1 mark for getting up to this point, and then you're going to get 1 mark for finding the basic angle as well. So that is how he's going to divide the 4 marks throughout. Clear? So do remember to show all your working as well. All right. Proving this question. Yes, Nofal. Did you do this? Parsa, did you do this?
I only did it half.
Yes, so I did it.
You did it, Parsa? Okay, Parsa, how did you do it? Tell us.
Okay, so this is it's gonna take a while. So
Okay, wait. I'll do it.
basically-
Just let me know if you've done it the same way or not.
okay.
Okay. Okay, I'll save you the talking. All right. Wait, now let's see. So we've got this identity that, we've got one side that I want to prove to the other. So what you may call is that we can simply do as, you need to prove one side to the other. You need to prove this side to this side. Now, what's going to simply happen is that I'm going to be taking this side. And the reason why I'm, trying to take this side is because of the fact that I've always told you that simplification is easier than expansion. Now, what do I mean by that? When I say that simplification is easier than expansion, what I essentially mean is that you're simply going to be what you may call, this is 2 fractions. These are 2 fractions, guys. And this is 1 entire fraction. So obviously you're going to simplify this to this. Now you can use either side to prove it to the other. My advice to you would be to use this side to prove it to this because it's going to be easier. Why is it going to be easier? Because simplification itself is very easy to do rather than your what you may call expansion, because this you're supposed to expand to this 2 fraction. This you're supposed to just simplify. Okay, let's see if I can get this right. So I'm going to write this down as tan theta plus 1 over 1 plus cos theta plus tan theta minus 1 over 1 minus cos theta. All right. Now, the first thing that comes to my mind is, because, the identity I need to prove it to is a single fraction. So I need to convert this into a single fraction. Now, if I convert this into a single fraction, I can simply, take LCM, the most common way to do so. So it's going to be 1 minus cos theta being multiplied to tan theta plus 1 over plus 1 plus cos theta times tan theta minus 1 over 1 plus cos theta and 1 minus cos theta. Now, this looks oddly familiar to me, this guy. And the reason why it looks oddly familiar to me is because to me, it looks like this, that, when you had A plus B back in IGCSE days, it had A plus B, A minus B. This was, this could have been written down as A square minus B square. So I can write it down like this. I have no issues with that. And also I can expand the above brackets too. So if I expand the above brackets, it's going to be tan theta plus 1 minus cos theta tan theta cos theta tan theta minus cos theta plus tan theta down to this two other brackets minus 1 times what you're going to have is plus, sorry, cos theta tan theta cos theta tan theta, and you're going to have negative cos theta over 1 plus cos theta and 1 minus cos theta can actually be written down as 1 squared minus cos squared theta. Now, 1 squared is 1. And this reminds me of simply what you may call, and keeping in mind that I need sine squared theta as my denominator, I do not require this. I can simply use the identity, which is sine squared theta is equal to 1 minus cos squared theta, which is the case over here. This is 1 minus cos squared theta. So I can simply replace this by, writing it down as sine squared theta. So I have just simplified my new denominator as sine squared theta. Now my denominator is starting to look like what I wanted to prove. Secondly, at the top, I'm going to have this tan theta adding up with this tan theta. So it's going to be 2 tan theta. And you've got minus cos theta. So it's going to be minus cos 2 cos theta. And everything else, I think, cancels out. Yeah. You've got plus 1, minus 1 cancels out. Negative cos theta tan theta cancels out with the positive one. So I can, literally shrink down my fraction size. Now, this is what it looks like. The denominator has already been proven to what I needed to prove. What is left is this part. Now, I just need to write it in this form. All right. I just need to write it in this form. How am I going to write it in this form? Just to simply factorize it. And this is going to be 2 times tan theta minus cos theta over sine theta. Over sine square theta, apologies. And you can simply say that hence proven. Clear, Parsan Oval? Does this check out?
Yes, sir.
Yes.
And Rahil and Amna, any issues?
No, sir.
All right. This was particularly easy. All right. The examiner is going to give you 3 marks. How he would have checked it. 1 mark for getting the correct LCM. And he's probably going to give you 1 mark for usage of this identity, the sine squared theta minus 1 cos squared theta, and 1 mark he's going to give you for the correct answer. That's how he would have checked it. So if you've got, if you've done 2 steps correctly, also remember one thing, it's not the case that you're always going to get uh, like the full mark by just writing down the answer. No, you're just going to get 1 mark for writing down the answer. Clear? Any issues with this, guys? Hopefully not. Let's continue. Oh my god, now we have to solve it. Okay, what did I prove it as? This needs to be solved. I can simply use this. My 2 cos 2 tan theta minus cos theta. I can simply use. Oh, why didn't it copy? Wait, guys. Footnotes is being a menace. Yes, finally. And this is equal to 0. Oops. This is equal to 0. Now, what's going to happen is that simply sine theta goes over to the other side. So you're left with 2 tan theta minus 2 cos theta. 2 cos theta minus is equal to 0. Now, I need to convert this into a trigonometric equation which only has one trigonometric identity. Either, take the entire thing into cos or make it into tan, sine, whatever you want. I just need to get rid of either one of them. How should I do this? Yes, guys. Parsa, any ideas? Yes, Parsa.
So don't you like represent tangent theta in terms of sine theta over cosine theta?
Okay, so Parsa is saying that I use the identity which is known as your tan theta is equal to your sine theta over cos theta. Oh,
Wait, Mr.
sine.
But first, can't you just divide by 2? Like you
Yeah, we can take 2
factorize
towards
and then you
0.
can divide by 2 to get rid of.
The 2?
Yes.
Okay, so both of you are telling me that I first need to get rid of the 2.
Yes.
Okay,
Yeah.
I'll
I
do
think
that.
that makes it easier to solve.
Yeah, sure. You're the boss. I'll divide everything by 2. Okay, if I divide everything by 2, now what do I get? I get
No,
tan
like
theta.
before, when we're multiplying, we just take 2 to 0. So directly we get tan theta minus cos theta.
It's the same thing. Literally. Okay. If I divide everything by 2 or if I take 2 to the other side, that's perfectly all right. Yes. Okay. Nofal and Parsa have bullied me into taking 2 to the other side. All right. What else? What should I do next?
Now
Guide
we
me
take
through.
cos theta to other side.
You want to take cos theta to the other side. So it's like tan theta is equal to cos theta. Okay. Then, okay, now I see what you guys are cooking.
Replace tan theta.
Smart. Sine theta over cos theta is going to be equal to cos theta. Then you are going to multiply the cos theta with itself. So it's going to be sine theta is equal to cos square theta. And cos square theta can actually be written as 1 minus sine square theta. All right, boys. So you did 1 minus sine square theta. Makes a very easy quadratic equation, actually. So it becomes 1 minus sine square theta. Now, I always like my square terms to be positive. I don't know why. So I'm just going to shift everything to this side. So it's going to be sine square theta plus sine theta minus 1 is equal to 0. Now, the easier way to solve this is let sine theta is equal to x. That is so easy to do. Now, what you're going to have is that you're going to have x squared plus x minus 1. Yes, guys, did you calculate for 2 values of x? Can you guys tell me what those are? Yes, Nofal and Parsa.
Mr. I got 0.62 and minus
Minus what?
1.62, but you have to
I
cancel
only got
minus
one value,
1.62 because
0.618,
the range
and then
for
final
sine is
38.
between -1 and 1.
Wait. Partha, just tell me the two values that you have.
0.62 and
Hmm.
minus 1.62.
All right, and Nofal, you are telling me you only had one value, which was what?
0.62.
Yes, and the reason why Nofal has only one value because this value cannot be used. And this is what I was referencing everyone in the previous question, where I told you that these two values were applicable because tan theta goes beyond infinity to negative infinity and stuff. So what happened was that over here you're dealing with sine. Sine theta remains in the bounds of 1 and minus 1. And also you have to settle the range. How do you settle the range? One thing that you need to know, if you're solving for theta and your range is for 2 theta or something of that sort, or if you're solving for 2 theta and your range is for theta, what will you do then? So you need to make sure that happens. All right. Just give me a moment, guys. Just a moment. Apologies. All right, guys. Apologies about that. Now that means that I cannot use this value. All right. This value is off the point. Just give me a moment. All right. Now I'm going to use this value alone. If I use this value, I need to also see that, this is technically equal to sine theta. So sine theta is equal to 0.62. Then theta will be equal to what, guys? Yes. Did you guys solve for theta?
Yeah, I got
38.2.
38.3.
38.3 or
Yes.
13? Is it 38 or 13?
38.
Okay, both of you did it, so it probably checks out. Now what's going to happen is that the range given to you is 0 to 90. Your theta is this. You can find the basic angle. Your basic angle is going to be sine alpha is equal to 0.62, which is going to be alpha is also going to be obviously equal to 38.3. Now, this question was extremely easy to do because your range was really, your range is given as very small. All right. You needed to look for your angle in the quadrants where sine was positive. In the first two quadrants, sine is positive. But the problem is your range is just over here. All right. This is your range. So now what's going to happen? Your basic angle is also here. Your basic angle is, uh, sorry, your basic angle is like this. It is 38.8 or 38.3. Therefore, your angle itself is also going to be 38.3. Clear? Any issues with this person? Open.
No, sir. No
No, sir.
question.
All right. And Nahil and Amna, anything that you guys don't get?
It's clear, sir.
All right. That is perfect. Moving forward, 4 marks. If we look into the division of the marks, it's very simple. You can, obviously any sort of usage of your identity is going to earn you a mark. So over here, you're going to get a mark. Obviously, you're going to get a mark for this. You're definitely going to get 1 mark for your answer. Oh, sorry, which is over here. And you're probably going to get 1 mark over to get this, to, get some sort of an equation and sine theta. All right. Yes, this was the question that you guys couldn't do, Nofal and Parsa.
Yes.
Yes.
All right, let's see to this question. How can we solve this? All right. Looks a bit tricky. Let's see how can we solve this. So the question was that show that the equation cos 2x and times tan squared 2x plus 3 is equal to 0 can be expressed like this. Okay. I'm going to first write down my equation. Just give me a moment, guys. Just a moment. All right, guys, let's see this question out. So what are we going to have from over here is that let's try to solve this question. How are we going to solve this question is, first off, I need to write down the question. That's the first step. So it's going to be cos 2x times tan squared 2x plus 3 plus 3 is equal to 0. Well, I'm just going to forget about the 0 because it holds absolutely no importance to it. The first thing that I need to understand is that there is no sign of tan theta in my equation that I need to prove it against. So I need to get this guy out. That's the only thing that comes to my mind. And tan square theta, whether it's tan square theta, simply tan theta, that can be easily written down as, your sine square theta over your cos square theta. It's just as simple as that. All right. So it's going to be cos 2x and it's going to be sine squared 2x over cos squared 2x. Just do remember that the angle that you're using, whether it's theta, 2x, 3x, 2a, 4b, whatever the angle is, make sure that the angle itself, you're just copying down the correct angle. All right, do not mess this up like that. Now what's going to happen is that it's going to be plus 3 over here, plus 3 over here, which is going to be easy. All right. Now what's going to happen is we can simplify the equation. So if I simplify the equation, what is it going to have? How will I simplify this equation, guys? Yes. So I can
Cos 2x and cos 2x cancel out.
so I can write this as sine square 2x over what you may call cos 2x, right? Because why? Because this cos 2x and this cos 2x cancelled out, the squared cancelled out. And you're going to have plus 3 cos 2x. All right, plus 3 as it is, and that is equal to 0. Now I have successfully removed tan theta from the equation. Now I just need to get rid of this sine squared thing. Now that is simple.
So don't you just represent sine squared in
Mhm.
terms of like 1 and
Yeah, simple. Yeah, that is what I'm going to do. It's going to be sine square 2x can be written down as the identity that I'm trying to use is 1 minus cos 2x. Oh, cos square theta, which over here is going to be written down as 1 minus cos square 2x over cos 2x. All right. Plus, it's going to be what you may call 3 cos 2x plus 3 is equal to 0. All right, guys. Okay. Now what's going to happen is that when you write it down further, now how will I solve this? What should I do now? Yes, guys, what should I do now? because I need to remove this. Everything else seems to be in place. There's only this guy that won't just go away. What should I do? Yes. The only thing that I can think of is, the easier way out. Multiply everything with cos 2x.
Cos 2x.
Yeah. I'm going to multiply everything with cos 2x. Now, what will that do is, that is simply going to make it as what you may call
So you do that, you get the quadratic equation, and then you do like
yes,
you,
Parsa. You're right.
yeah.
So it's going to become like this. 3 cos 2x. If I have expanded the entire equation just by multiplying it with cos 2x, why did I do that? Needed to remove this. This cancels out when multiplied with this. When you multiply cos 2x with this, it becomes cos square 2x, and this becomes 3 cos 2x. Now you just need to do what? What do I need to do, guys? Simple rearrangement, and we're going to get our answers. So what is there to be left now? You have to rearrange it. So I'm going to have this minus cos square 2x plus 3 cos square 2x is going to turn into 2 cos square 2x. And it is going to be plus 3 cos 2x plus 1, which is equal to 0. Hence, we proved it. All right, guys. Any issues with this? Yes, guys, come on. Tell me if there's any. Just give me a moment as well. All right, boys. Any issues?
No, sir, no issues.
All right, that is perfectly all right. Okay, now this is very simple to solve. This is a quadratic equation in cos. Can you not solve a quadratic equation in cos?
Yeah, you can.
Yes, Nofal, is this clear?
Yes, sir.
All right. I've tried to blitz through the questions, but obviously we've run short of time. Which other question could you guys not do?
So I also didn't do the third one.
This one?
Yeah.
Okay. And what about this one?
Yeah, that one I did it.
And okay. So only 2 questions are left, guys. All right.
Yes.
In our next class, I'll try to do is try to send you guys a solution for
Okay.
this. All right. I'll post the solution on Google Classroom.
All right.
Clear? Okay,
Yeah.
boys. That's it. Look at the school feature and good notes. Like now the tape is colored.
Yeah.
All right. Keep smiling, boys. I'll see you on Saturday.
Mm.
Allah Hafiz.
Take care.
Bye bye. Bye bye.
Bye.